now for our feature presentation. I'd like to introduce Sam Nasr, Senior Software Engineer of NIS Technologies. He's also an MVP, I believe. I've known Sam for many, many years. Sam's a very good developer. He's really the .NET guy. He's been involved with the Cleveland .NET user group for a very, very long time. And Sam's a good guy, and looking forward to hear what he has to say about Azure and decision intelligence. So Sam, I'll stop my sharing and let you go ahead and share out.
Very good. Well, thank you for that introduction, Craig. And yes, it's been a pleasure knowing you for all these years. And as Craig mentioned, I am a strong .NET guy. I always tell people, not only did I drink the Microsoft punch, I overdosed on it. So I am Microsoft through and through, and Azure is definitely one of my favorites. So let's launch into tonight's presentation. A little bit about me. First and foremost, my Twitter handle, @SamNasr. And I've been a software developer since 1995, which probably puts me in the ancient category right about now. I'm a senior software engineer for NIS Technologies, where I do training as well as consulting. I've been certified with a few certifications from Microsoft. And I also run the Cleveland C# VB.NET user group, as Craig mentioned. And I also run the .NET study group, which meets online. In addition, I've authored upwards of 17 articles for Visual Studio Magazine, and I've been a 5-time Microsoft MVP. Just a little shout out to the Cleveland C# VB.NET user group. We meet every month. The meetings are free of charge and open to the public, and we cover all topics related to .NET. So we also cover SQL Server, Azure, and anything in between that touches .NET. Meeting information can be found on meetup.com, where past meeting information as well as future meetings are going to be posted there. And we will be meeting in December, December 14th for our next meeting. So with Azure Cognitive Services and Decision Maker, basically, it has been relabeled Personalizer, and it is now within the decision category of Azure Cognitive Services. And as you see with Cognitive Services, it offers a variety of different services, and under each service, or under each category rather, is a plethora of services. So we fall under the decision, and there's Personalizer listed at the bottom of the slide. So the big question, what is Azure Personalizer? Basically, it's an API service that helps your app to choose the best content to display to your users. And it's formerly known as the Azure Custom Decision Service. And it being that it's part of Azure, it's naturally a cloud-based service. And it's part of Cognitive Services I mentioned earlier. The service essentially monitors the user behavior and helps to pick out or help predict what the user selection will be. And then it makes recommendations based on that. In addition, to help the model better learn what the user preference would be, there's a reward score mechanism. And basically, we reply back to the service with a reward score ranging from 0 to 1, 0 being an absolute no, 1 being an absolute yes. They can also offer ranges in between 0 and 1, 0.8, 0.2, depending on the type of items that you are displaying to the user. So this helps to ensure continuous improvement of the ML model or the machine learning model. Now, some terminology. Actions. When we refer to actions, basically it's the content or the items that we're displaying to the user. This could be any unit of information, could be a text, an image, a URL, or anything that we're essentially displaying to the user. A feature. Think of a feature essentially as a property, something that will help better describe that specific item. So it could be a size, a color, a cost. And we reply back with the score of 0 to 1 to help identify whether we're on target or we're not. So how does it work? It utilizes reinforcement learning, or RL, to select the best item, also known as action, as mentioned previously. and it uses the collective information in near real time. So we do submit the call to the API service. There is a little bit of latency, and that latency increases with the number of items. So it is near real time for all intents and purposes, and it returns with a single best content item from that list that we submit to the service. This is based on collective behavior as opposed to a single individual user, and then it collects the rewards across all the users and then helps to build the ML model out of that. Within the service, we use the rank method, and this essentially takes all the action items and the features, and it submits it to the service, and then basically replies back with the top action item that fits that specific scenario. So essentially, we have a list of items or actions, such as, let's take food items, for example. We have salad, we have ice cream, we have cake, and we submit that to the service, and then the service responds back depending on the other context around it. It could be date of time, it could be date time, could be user gender, could be a variety of other things, but then the service will reply back and say, what's best for this user is this action item. And so we use the rank method to help determine that. Likewise, once we get the action item back, then we can use the reinforcement learning and submit a reward. And that reward is ranging from 0 to 1 to show the model whether it's on target or it's completely off. So this is a summary of essentially how the entire personalizer works. So on the left of your screen, you see that we have the user interaction with the application. And then you see step 1 for the rank API. What's happening here is we collect all the user information and the context of that specific action. And then we have the actions and the features that we're going to be submitting to the service. So user information and context could be things like the date, time, age, any identifiable information or metadata for a user. And then we have the action items as far as what are the possible items that the user can choose from. We take those 2 items, or those 2 collections of things, I should say, and we submit them to the service using Rank API. So that's the first call we make. It goes over to the personalizer service in Azure, which is listed on the right-hand side of the screen. The service then does the plug and chug, identifies which one is the best item for the context that's presented, and then it responds back with a rank response, meaning I think this item would best fit this specific user for this specific context. Then we take that item, we display it to the user, and we help to better retrain the model. So we ask the user, is this correct or is it not? And we can respond back with a score. In this case, you'll see a score of 0.8, and then that is sent back through the reward API call in step number 3. Okay, so essentially it's a 3-step process. We make the call, we get the response, and then we use reinforced learning by submitting a reward back to the service. Okay, everyone with me so far, or any questions? All right. So moving on, to set this up, because it's in Azure, the first thing that you need to do is to have a Azure portal account. This will require a subscription to the service, and you could get one free of charge just simply by signing up. If you're an MVP, you also get, I think, $150 to use. So that makes it convenient. And then once you get the subscription service, then within it, there are different fee levels or pricing tiers for the services that you're going to be utilizing. In this specific example, I use the free service, and I'll show you how we went about that. So you create your Azure portal account, you have a subscription. The next thing to do is to create the personalizer, and that is a service which has to be tied to a resource group. If you've used Azure, you'll know that everything done in Azure has to be tied to a specific resource group. That essentially just ties everything together into a specific group, so it makes things easier for modifications and movement later on. The third and final step is to utilize the API key and the URI that you will get after you've created the personalizer service. And so to better explain it, a demo is always handy. So looking at my screen, what I have is a console application written in C#. But if you recall, the first step is actually creating an Azure account. So going into my Azure portal, you'll see that I have a personalizer RG, which is a resource group. So I have to create that first. And then, excuse me, I would create the service simply by clicking create a resource. And then I can go either and search for it manually through here or search through AI and machine learning, or I can just take a shortcut and type it in the search window, and personalizer comes up. At this stage, I can click create, and then I'm on my way. I won't do that in this case because I already have one created. So let's go back to my home screen, and there's my personalizer that I created, NIS personalizer. When we open that up, you'll see that you have a variety of different options to choose from. First and foremost, getting the API keys. So the API keys are, I won't be able to show you that because that's confidential information. You want to maintain your API keys under lock and key. That's equivalent to your user account password. So you don't want to distribute that. But once you create a service, it assigns you an API key as well as a URI or a service endpoint that you'll need to call with the API key in order to target your specific model. And here are my keys and endpoints. So as you see, keys, being that they're protected, they're shown as dots. And then here's my own personalized endpoint that I will be using, and then the location of which Azure location I'll be targeting. In addition, the pricing tier. I have two different tiers for setting up the pricing. In this case, I chose F0, which is free, and I'll touch more on that later. So I've gotten to the point where I've created my account. I got the personalizer service up and running. I have my keys and my endpoints. I can then take those two items and use that in my application. Now you'll notice that I have two keys. Either key will work. And the advantage of having two keys is if one key gets out into the public, I can change it and use key 2. My application will still work just fine. And then I can regenerate key number 1. Okay, and then here are the buttons up on top for regenerating keys in case you need to change that. And it's always good procedure to change it every so often, just like we do with our passwords. And if I go back to my application, actually, before I do that, let me just check the chat window. And so far, there are no questions. I should have also mentioned, feel free to jump in at any point in time with questions or comments, either verbally or through the chat window. All right, so what I have here is a console application written in .NET Core. And essentially, I need to utilize these two libraries, which are available through NuGet. And this is targeting the personalizer and the personalizer model. Because it's a console application, my entry point is main. And what I'm going to be doing is getting a list of actions. And if you recall, we said actions are a list of items that a user can choose from. So let's go ahead and jump to that method. Cannot navigate. Let's try it again. There we go. Okay, so my list of actions or items that I'll be presenting to the user are basically food items like I would on a menu. So I kept this fairly simple. Actually, this was the example that was used on GitHub. So I have cheese, pasta, ice cream, juice, and salad. So obviously, the majority of these are edible items, right? With exception of the juice. And just like everything else, each item has a specific set of features or properties. And so looking at the cheese, one feature of it is the taste, which is salty. It may also have a spice level, depending on what type of cheese it is. And like all food items, it also has some type of nutritional value. So I assign these values to them as features, which is a list of objects here. So what's common across all these is the taste feature, and that's listed in all of them. Some have spice level, some have nutrition, but not all of them are consistent as far as that goes. In addition, aside from these rankable items, like I said, all of them are edible except for one, which is juice. And we'll see why we put that in there intentionally. So, as I mentioned, the first thing to do is we get a list of the actions that we're going to be presenting to the user. Then we initialize our client library where we're going to be making a call to the service. And if you recall, this utilizes the service endpoint. So this is a string variable that I've hidden elsewhere in the code. And essentially that's the URI that I'm pointing to. And it will also be utilizing the key that I've also keeping safely. And so the next thing that it will do is it will get the user's time of day. So this is the context. We want to find out, is it morning, afternoon, evening, or night? And then we also want to get the user's preferences. So what we're doing is we're getting the user's time of day, and then we ask them, what is your taste preference, salty or sweet? And then we combine both of those, as you see here, in a list of the current context, and we submit that to the service. So here's current context. We already have our list of actions up here as actions. And so as we scroll down, you'll see that we have an exclude actions item. So because juice is not a food item, we want to exclude it from that list. We can do that dynamically in the code where we can just simply create a new list of excluded items and add the juice to it. Every time I make a call to the service, I have to assign it a GUID, a unique identifier. So when it responds back, I know which event it was referring to. So, pardon my scrolling. So here I get an event ID, which is essentially just generated by a new GUID. And then this is where the rubber meets the road. So I make the call using the rank request, and this is the action method that I'm initializing. And I'm passing in my actions, which is the list of menu items, the current context of the user, i.e. the date or the time, their taste preference, that's all in the current context. Items that I want to exclude, and then the event ID, which is a unique identifier for that specific event. I submit that to the service. The service then responds back with a response, and then it's giving me a rank regarding which items that I've submitted. So I'm taking this request object that I submitted, and I call the rank method. And what this does is it basically finds out the ranking of the items, and then I'm able to display those. And as you see here in the following for each statement, I'm going through the response ranking, and the response is the response object that I got back. And I'm reading each individual object, and I'm looking to see what is the probability of the ranking depending on the context according to the service. And this is just for demo purposes where I'm just displaying all the items as well as the probability of how well they fit that context. And then in the end, I make a final judgment call, and I tell the user that the personalizer service thinks you would like to have whatever this reward action ID item is. And then I ask, is that correct or not? And depending on the answer, I will apply either a reward of 1 or a reward of 0, depending on what the user responds with. So then the third and final step, where now I am sending the reward back to the service, that is done using the client-reward. Now, if you recall, I said that this is a web API service, right? So where am I making the actual web API call? I'm actually utilizing the SDK, which is done by these two NuGet packages. And so that web API call is actually happening inside that SDK. So all I need to do in my code is just simply reference the methods and be able to retrieve the results from there. And forgive me, I lost my place. So we were here last. So this is the third and final step where I've gotten the response back, and now I'm submitting my reward back to the service and saying yay or nay, essentially. Okay. So let's go ahead and go through a sample run. So as I mentioned, this is an iterative process. And so you see that we're starting with iteration number 1. It is now asking me, what time of day is it? Morning, afternoon, evening, or night? So let's go with morning. What type of food would you prefer? I prefer salty. And so now it takes the list of items, submits it to the service. Now the service has responded back and assigned probabilities to all these items. And then there you see a listing of the items and that probability. So for salad, it gave it 0.85, cheese 0.05, pasta, so on and so forth. You'll notice that juice is set to 0 because we excluded that from the list of items. So because salad is the highest ranking in that list, it responded back with salad. So now I'm being prompted, the personalizer service thinks you would like to have salad. Is this correct? I will click yes. And what this is doing is essentially sending a response of 1 back to the service. So now when I hit 1 again, and I'm going through a second iteration, I will say morning, and then I'll specify salty again. And so it's learning that morning and salty usually equates to salad. That's just based on the training model that I had done here and the sample iterations that I have. Keep in mind, I only have five items that I'm submitting to the service. So again, this is for demo purposes, keeping it short and sweet. And so it helps to identify the items rather quickly. Okay. I want to stop for a second and see if there's any questions.
So I have a question.
Sure.
So the more times you run this thing, right? And obviously, let's say you have 100 users running against it or something. But does the back end service remember the choices that are made and build that into future responses?
So the short answer is yes. The long answer is it doesn't tie it to any specific user, but rather it looks at the context. So, for example, it doesn't know that Sam likes salty things in the morning, right? It just knows that most users, from the input that it's received, that morning items, the preference is salty items.
So it's keeping like aggregate data on
exactly
choices
right
time. Okay, thank you.
Very welcome. Any other questions? Okay. So essentially, we continue to run through several iterations, and the whole point is you want it to learn through multiple iterations. And again, it's just a simple collecting the information and the context, submitting it to the service, getting the ranking back, and then rewarding the service, quote unquote, for the score that you received. I have a question in chat. Did the personalizer have a basis for the responses first to come up with a salad? Per your response, then the other people who have used the service seeded the percentages. That is absolutely correct. So I've used this before and kind of seeded some responses in it as a training model. And actually, we can jump through to the portal at this stage. So not only is the portal used for setting up the service, but also you have a variety of different settings. And so here, looking at the model, It shows that it was created on 11/14, which is 5 days ago. And then it was last updated at 11/19 at 5:14 p.m. today. Okay, so I can choose to clear the data and purge it of everything that it has learned so far and start over again, or I can actually export the model using the export learn settings here. Excuse me, the export model button here. Another question, could you please show the ML model that you used to train? So the model is essentially embedded in the service. I call the service and then it automatically builds the model for me. The closest thing I could do is export the model as you see here, and this is just a binary file that I downloaded. Couldn't even open it in any file editor, but everything is kept inside the service itself. I can export the model so I can share it with another service. Let's say my company has built the model, it has trained it correctly. Now I can turn around and sell that model based on those items to other vendors. So I don't have precise control over it. It is more of done through the service, and I have the ability to export it. And there's a couple other settings that I have. Does that answer your question, Samitha? Forgive my pronunciation. Okay, very good. And Marianne, I didn't ask for a confirmation. Did I answer your question as well? All right, very good. So while we're in the portal, let's take a look at some other settings. With configuration. So I can configure it where the reward time. So even though this is a simple application where I'm getting the ranked items and then I'm replying back yay or nay, depending on the application, being that it's the web and there's latency, there may be cases where the user just simply drops out altogether, and so I won't be replying back with a reward. And so you can have a setting here where you're giving the user X number of minutes before you submit a default reward, as we see here. And so the default reward is 0 after 10 minutes. That's just one of the settings that I have. In addition, how often do I want to update my model? Because this is a brief demo and I want to show the results relatively quickly, I changed it to 5 seconds. Obviously, this is taking a lot of work on the back end to rebuild it every so often. Thankfully, it doesn't impact my billing through Azure, but I do have the ability to update the model rather regularly. And then lastly, there's a setting down here for data retention where I can specify the number of days to retain the data. So it is not so much that it is tied to any specific user, but rather it's an aggregate across all the user base. Also, pricing. Taking a second to load. It doesn't show well here, but I have it on another slide. Essentially, I have 2 pricing tiers. The free one allows you 50,000 transactions per month. And then if you have more than that, 100,000 and upwards, you can use the S0 or the standard pricing tier. And we can jump back to our slides. All right. So we got a good idea of how it works, what's needed to set it up, and some of the things that are incorporated in building the model. Let's take a look at some limitations. So as you had seen in my demo, I only had a list of about 5 items or so. However, that's not going to be the case for every scenario. You are limited to a set of approximately 50 items to choose from for that specific machine learning model. If you're going beyond a larger list or a list of higher than 50 items, it is recommended to use a recommendation engine. And there's a variety of them that are available on GitHub that will essentially help you reduce that list to something a little bit more manageable. So the content has adequate information, meaning that we submit the actions along with the features and the context features. So if you recall, actions are the list of menu items. Features are whether it's salty or sweet, nutritional value, etc. And then context is essentially the context of where I'm submitting that user request. So, i.e. the date or the time of day. Now, to build it, you would need approximately 1,000 transactions a day of content-related events in order for Personalizer to be effective. Being that it's a demo, I haven't gotten to that level, but essentially, if you want to increase your accuracy, you're looking at 1,000 transactions minimum in order to get to be a more effective personalizer. And if not, the service then just takes a little bit longer to determine the result. And like I said, there is a little bit of latency. For our purposes here, being that it's just a list of a few items, it really didn't appear to have that much of a delay. But as the list grows and the model is not so trained or not trained very well, then that's going to increase the latency time. Also, as mentioned previously, this is tied to collective information in near real time. So it will return the single best content item. It does not persist or manage user profiles, but rather it's the entire user base as a whole. And also because it doesn't maintain user information, it doesn't log individual user preferences either. And of course, it doesn't require the data to be cleaned and labeled. Essentially, we're submitting the same context and the same action items. So there isn't the cleansing process that's needed in most machine learning processes. So for pricing, we touched on this earlier, but this is a little clearer to read. So as mentioned, with the free tier, I have 50,000 transactions a month and up to 10 gigabytes of storage. If I go beyond that in the standard, then there's an additional pricing sub-tier that's listed there, depending on whether I'm using 1 million, 9 million, or more. And as you see there, the price starts to decrease per the number of transactions. Of course, you'll be paying more total, but the pricing per transaction decreases. Now, keep in mind that because this allows you to pick up a user preference or based on a collection of users, you can also use this in a conversational bot. And so some of the things to consider when using this for a bot is that it requires real-time access for Personalizer every time a rank selection is made. So with a Personalizer, let's say that I'm using this with Lewis or text-to-speech. And so I'm converting the text into speech. I need to be careful of the latency that I'm going to have with my user so it doesn't sound like my bot is falling asleep and responding to the user. Again, this depends on the number of items, the number of action items, and how well my model has been trained. Unfortunately, the rank API, as we had seen, cannot be batched or cached. So it has to be multiple iterative calls that occur. And the reward call can be delayed or async. So depending on when I respond back to the service, if you recall, there's an event ID that is tied to every time I submit and receive a response. That event ID will help to essentially tie that event with that reward. And so because of that, I can delay my reward call, assuming I don't increase the maximum time set for the reward. And if a reward isn't returned in a timely fashion, depending on the setting that I have in my portal, then a default reward is set, as I had shown you earlier. So that pretty much sums up today's presentation. I just wanted to stop and ask any questions before we wrap it up.
Yeah, Sam, I have a question.
Sure.
So I guess the use case that I see in this is, let's say I have a like a shopping cart application kind of thing, and let's say I'm going to buy lumber online, right? That's kind of a silly example, but let's say I'm going to buy lumber, and if I do that, and let's say I buy nails at the same time I buy lumber, and then could this be used to present that to somebody else that is getting ready to buy lumber and say, oh, well, you bought lumber, you might want to buy these nails too. Is that am I on the right track there or no?
Yeah, absolutely, exactly. So it kind of like groups the items together as far as, if you buy one, and again, it's based on a collection. So it's not just a single person going into the store and making that one purchase, but rather if we see a trend of, let's say, out of the 1,000 users that I've used to train my model, and 700 of them bought nails along with lumber, then naturally the 701st person will have that recommendation made to them.
Okay.
Make sense?
Yeah, absolutely. Obviously, probably the big giant e-commerce sites like, Amazon and Google, they probably have their own engine written to do this type of stuff. They're probably not doing it in .NET. But
yeah, and keep in mind there's a lot of ways of going about this to kind of match selections. Like in the past with web development and database development, we've always used meta tags and kind of tie items together, right? So that's one way of doing it. The predictive purchasing logic has been around for quite some time, and they've, again, different methods of doing it. What's nice about this is that it kind of abstracts all the headaches away from me, and I just basically make service calls and I get the answer back. The only key is that I just need to train it. So that's the beauty of it.
good point. Are there any, if anyone else has any questions, feel free to put them in the chat window there, or open up your microphone and feel free to ask Sam, and if you have anything.
So typically when I'm presenting in person, I always like to ask, what did you learn today, right? How effective was I in delivering the message? I know that it's not as interactive when we're doing it online, but I just wanted to show you the slide one more time, just to sum it up. Again, we have the user interaction with the application. And then when we make the call to the service, we collect the user context. In our case, we collected the time of day. And then we collected all the different menu items. We submitted that to the rank API. And then because I specified that I like salty and it's in the morning, it responded back with a salad. And then it asked me, was that salad the right item? And I responded back with a reward of 1. So it's a 3-step process here for every call. Some references that would come in very handy if you're interested in learning more about this. Microsoft Docs has a great write-up on it, and the link is listed there. Also, some design considerations if you're using it to build a bot, more specifically a speech bot. And then last but not least, everyone's favorite topic when it comes to this kind of a thing, pricing. How much is it going to hit, and am I ready for it? So obviously, in our case, being a short demo app, the free pricing tier, it wasn't a problem. And you can use that to help train your model and get it up to par. But then if you're actually using it, like you're one of the giant retailers, obviously the free pricing tier isn't going to cut it. And like I mentioned, there's also multiple sub-tiers within the standard pricing tier. I see there's a question in chat.
I'm not seeing those. That's interesting.
It only shows to the cool people, Craig.
Oh, I guess that's the case. That's
just
okay.
kidding. Okay, so the question is, have you posted somewhere the data set to public access? I assume you're saying the data set that I'm using. It was really, I mean, the example is available on GitHub, so I really wouldn't call it a data set. It's all incorporated within the application just as menu items. So short answer is yes. And then we have another question. What other types of APIs are there in Personalizer besides the ranking API? There are some settings, some APIs for setting and changing the configuration, so you can do that programmatically. But essentially for your conventional calls where you're submitting the rank API, getting the ranking of where those items are for the user, and then the reward. Those are essentially the three primary ones that you're going to be using regularly. But there are others for different settings, purging the data, clearing the model, that sort of thing.
Okay. Any other questions or comments? So, Sam, applause there. Thanks, Sam. That's
Thank
a
you very
great
much.
presentation.
Appreciate it. Before I leave, just wanted to let you know my contact information listed here. Just because of the meeting's over doesn't mean that we have to stop the conversation.
Mhm.
Any questions come up later, you want to download the demo and work with it, or you run into any problems, feel free to reach out to me, snasr@nistechnologies.com, or on Twitter. And I also invite you to connect with me on LinkedIn. And I see 2 items in chat. Thank you for organizing the event. Thank you for joining us. Thank you all. I appreciate it. Thank you for having me.
Yep.
And hope you all have a great Thanksgiving. Stay safe. And thanks again.
Yep. Thanks, Sam. Thanks everybody for attending tonight's this evening's event. We hope you, again, as Sam mentioned, we hope you stay safe and have a happy holidays. So watch out for the survey, and we'll see you back in February for our February meeting. Have a great day, everybody. Good job, Sam.
Thank you, sir. Good night, everyone.
All right. Good night, everybody.